Welcome guys to our summative project on the auto garden. This is presented by Andy, Danny, and I. We're just going to show you our product and how to grow different.
Now, our product is inspired by the $150 Smart Garden by Click and Grow. Inc. The Smart Garden is a standard model that provides basic watering and lighting to garden plants only. Plus, relatively speaking, it is large and moderately expensive. But why pay so much for such a simple product when we can design it ourselves with much more utility enhancement? This should be interesting Arduino project to reproduce and innovate, all while adding our own twist in both hardware and software. This trending product has only become common throughout the last couple of years. This is not only a great for colder regions such as Canada, but also for avoiding outdoor pests. The greatest fine art of the future will be the making of comfortable living from a small piece of land. The history of agriculture goes all the way back until when humans decided to settle by using farming as a method to provide food and unknowingly contributing positively to our environment. However, since then, the grand scheme in agriculture hasn't changed for the last couple of decades, and we are only possess more advanced tools to maintain and harvest. Now, in the past few years, the concept of automated gardening has emerged that allows users to grow plants with a bare minimal effort to take care of it on a small gardening scale. Current and future applications. The current applications of our product includes water the plant autonomously to keep it hydrated at all times based on moisture level. But we also add a twist of keeping it constantly under artificial light or if by natural sunlight if possible. Our smart garden does not only require any previous knowledge or experience growing plants, and the growth process is controlled by the technology, resulting in a higher success rate. Indoor smart gardens usually grow plants 30 to 50% faster as they are designed to provide the best condition for specific plants to grow. Because of this, they also contain more nutrients. This is of course a long-term investment where you will see a gradual return with. Some of the future application with is that our small-scale automated garden still requires much human labor to harvest and transport manually. This is why we decided to innovate, which we built on an additional complicated feature enhancement that allows a gardening bot to move itself around freely. But in the near future with investment, if we're able to replicate our robot thousands of times and dictate the movement of each individual bot instead of by light, but by a central factory that recalls all the small gardening by with mature crops to a central factory, which is responsible for harvesting and storage. This will limit the use of man labor to the minimum of barely none, achieving an evolutionary innovation system of agriculture that allows for the full automation. This small gardening bar will serve you not only your current gardening needs, but also the possible future application of automated agriculture. While our robot makes a great resemblance to one of the most famous sci-fi movie concept there is, with innovative thoughts and acts, we were able to create a somewhat resembling robot to Wall-E as a school project. Though it's not competent or equipped as broad range of functionalities, however, in the near future, those concepts will become a reality.
Now you're probably wondering, how is this made? How is our product created and the ups and downs that we have faced? Let's start with the components and applications. So for components, we have the motors and the L293D chip, which in the software we would just use to drive the motors and go forward, right, left, and such. For the another hardware we have is an ultrasonic sensor. We use this to sense and calculate the distance, making sure it's safe enough for the car to drive. We also have a servo hardware to turn left and right for the ultrasonic sensor to calculate more distance, whether it's safe to turn left or to turn right or to go forward. And we also have another photoresistor, which is also called a light sensor. This is used for just seeking natural sunlight, going where it's most better for the plant to go to. Next, we have a moisture sensor. This one would read the moisture and see if the plant is dry. If it is dry, it will activate the water pump system, which is another hardware component that we have, which is just to send water to the plant when it is dry. Another hardware we have is an LED system. It's just the fairy lights of LEDs that go around the bot. It makes it look pretty. It will turn on when it's dark and there's not enough sun and give it enough support. All you have to do is just add water. Next, we're going to go through the progress timeline. We first started with working with a servo, making sure that it works with ultrasonic sensor, putting on top of the chassis, making sure the auto drive mechanism was running and fully working. This took from December 1st to December 3rd, about 7 hours. Then the next time we came back to class, we worked on building the box with the plant, a nice showcase for the components of the water pump system and the plant. This took place December 13th to 14th for about 5 hours. Next, we have the LED lights, which took place from December 15th to 17th, about 7.5 hours. We were just working the LED lights along with the light photoresistor, making sure that the lights turn on when the room is dark. Next, we were making room for the electronics inside the chassis, just to reorganize everything, make sure when we put the actual physical box for the plant, that it will actually fit on top of the box. Okay, and then next we worked on the water pump and moisture sensor, making sure that we can sense whether the plant is dry, and then when to send the water to the plant. This took place from December 22nd to 24th, about 7.5 hours. And then that was, this was happened during our break. So this is actually time we took out to work on the bot right before Christmas. After Christmas, before New Year's, we decided to just work on a little bit more. From December 27th to the 31st, about 7.5 hours. We were just working through the powering issues and assembling everything together, making sure our final physical product is working, and then just wrapped it up, prepared documentation, and created this presentation for you guys. Here we have just some pictures for the bot, how it started out, and then how it turned out. We started with the basic bot with Arduino and breadboard on top. This is just for the basic movement for the servo and ultrasonic sensor just to move around. Then we moved on to the plant housing just to make it pretty and all nice for the presentation, making sure that the plant was safe. And then we moved on to the LED lights, adding some flare, making it pretty for the light. So when it's dark. Then we moved on to the water pump and also the moisture sensor, making sure that the watering component works. And then finally, we added it all together right there. And then you're probably wondering, it was $150 for the smart garden that we presented from Click and Grow. Well, that's not necessarily how much you have to pay for this kind of product. In reality, we paid about almost $12, $11.94. Just paid for the moisture sensor and the water pump. All the other components were provided or repurposed from other projects like the LEDs and Arduino and breadboard and other sensors. If you did want to build this project yourself, you can see the full list of components and the approximate price on how much that would cost. So it would be about $60, maybe less, maybe more, depending on how much you want to embellish on the product. Here are just some demo videos for the bot and separate functions.
So the conclusions, possible improvements and recommendations. With further development and funding, we will be able to make our smart garden fully self-dependent through the potential use of regenerative braking, solar panels, and self-docking. These self-dependent features are necessary improvements for the wide adaptation, like the Roomba. Creating a feature such as self-docking, our garden, will learn to get back to the dock to charge and refill for water. Future improvements could also include AI mapping the environment and learning from its mistakes, and possibly learn where the best spot for sunlight is during the day, during a certain time in the day. Lastly, we could include a size upgrade so our garden could use a larger and stronger electronic parts, allowing it to hold more weight, resulting in better harvests. Each feature, the challenges, each features of our bot worked perfectly fine on its own. We did many tests with the code and hardware that performs each feature. The performance of each function were great. However, our excitement came to an end just as we were about to assemble the bot together. After assembling, all the features of the bot would only move very slowly, as well as the water pump. It wouldn't pump the water past the height of the tube. After careful observation and group discussion, we suspected that this was due to a power issue and tested different power delivery methods, including a battery, a power bank, and a USB cable. Unfortunately, after consulting with the teacher, he recommended a barrel jack, which we did not have, and we ended up choosing the power bank as the best method of powering the bot and the battery as the next best. So, the outlooks and futures of smart gardens. As we become more dependent on technology and automation, why is there a lack of innovation in gardening and for the environment? That is because we only recently become aware that technology can actually be useful in our task of climate change and helping the environment. The emergence of smart gardens are just a small part of what we can do to better nutritionalize ourselves, but also save the trip to and from the grocery store to buy an herb shipped from halfway across the planet. This is why the future of this technology is just beginning to sprout, as not only our plants, but products will flourish in this age of caring about our environment and diet, even though that the stay-at-home pandemic caused a surge in the interest. There is no doubt that people are hooked on gardening and is gradually making it into more homes.
Right, shameless self-plug. That's my website, trungrobotics.xyz, if you want to see more information on the project. It's just a public version of the documentation that you guys can view yourselves.
So that is the end of our presentation.
Thank you for listening and have a great day. And here's some of our bloopers.